This is the second part of the amines tutorial clip. This tutorial is about making aliphatic amines, that means straight chain amines. So the first way of making an amine is in the reaction of a haloalkane with cyanide ions, followed by hydrogenations, that means the adding of hydrogen. So here's an example of that reaction. The haloalkane, say bromomethane, reacts with potassium cyanide, and it makes this compound here, ethane nitrile, with potassium bromide as the other product. And then in reaction 2, the ethane nitrile formed in this first reaction is hydrogenated either with lithium tetrahydrido aluminate or with hydrogen and a nickel catalyst. And with the LiAlH4, that is the reaction there, with the H is the reducing agent for the reaction. So the first step is a nucleophilic substitution reaction. The cyanide attacks the carbon as a nucleophile and the bromide leaves. And in the second stage, it's a reduction, the addition of hydrogen to the nitrile group. Notice that the carbon chain is now extended by 1, so an advantage of the using cyanide is you get a lengthening of the carbon chain. Another other advantage is that you only get one product with the reaction with the KCN, one amine product I mean. We'll look at the other way of making amines later, and that forms many amine products. The disadvantage of this method is the use of potassium cyanide, which is a toxic chemical. The second method of making an amine is the use of a haloalkane with the reaction of ammonia, something you learnt about at AS. So it's again a nucleophilic substitution reaction, and so the ammonia reacts with the haloalkane. Ammonia is a nucleophile. The second ammonia is a base, removing the proton from this methylammonium cation, and then forming the methylamine product, ammonium ions and then bromide. They connect together to form ammonium bromide. Having said that, the amine group formed, methylamine formed in part 1, can actually react again, and it can react with a second haloalkane molecule. So this is a brand new molecule there, with again ammonia acting as a base. And so you form this product, dimethylamine. And you'll notice again this is a lone pair. So this molecule can also act as a nucleophile, can react with the methylamine to make trimethylamine, ammonium and bromide again. You can see the similarity in the mechanisms on the right hand side there in purple. And then this product as well, it's got a lone pair. It can also act as a nucleophile with some fresh CH3Br, this time making only one product, and that is a Cortinary ammonium salt. So it's got 4 methyl groups, hence Cortinary, and it's a salt because it's a positive cation, negative anion. So these products will need to be separated by fractional distillation. There is an advantage of this in that this product can be used in hair and fabric conditioners. A disadvantage though is that all these different amine compounds, they need to be separated, and they can be separated by fractional distillation, but it does make the process a little more difficult. To prevent this from happening, i.e. all these different products being formed, if you have a large excess of ammonia, this encourages only this reaction to take place. Now a brief look at making aromatic amines, that's amines with a benzene ring. And this is an overview. So we have benzene, nitration reaction to nitrobenzene, and then reduction to phenylamine. So let's look at how this reaction takes place. Two-stage process. Benzene reacts with nitric acid, which is concentrated, and concentrated sulfuric acid catalyst makes nitrobenzene, and also water as the byproduct. Look back in your benzene notes to find out about the mechanism. And then the reduction of nitrobenzene is the second stage with tin and hydrochloric acid, which is the reagent, and supplies these H's here. And this is the way we write the reaction with 6H as the 6H as reducing agent. Phenylamine is the first product, and 2 moles of water as the second product. The oxygens have come from the nitrobenzene. Now, because there is HCl present in the reaction, and it's that obviously that's an acid, this is a base, these two can react to form phenyl ammonium chloride. And so to get our organic product, we need to add sodium hydroxide, which is a strong base. The hydroxide removes the proton from the phenylammonium. The Na reacts with the Cl, so we get phenylamine, our target product, NaCl, and water as the final product.